Good afternoon. Welcome to the second of the scheduled ETSI webinars on the OSM Release 7. The second part is being on the running of cloud-native network services with OSM. My name is Gavin Craik, and I'm the Senior Technical Content Officer at the ETSI Secretariat, and I will be your moderator today. The webinar will provide a deep dive on how to deploy cloud-native network functions on Kubernetes with OSM, using either Helm charts or Juju bundles, and how to benefit from the new automatic placement feature in OSM for edge deployments. We have three presenters today: Gerardo Garcia from Telefónica, who is also an OSM TSC member, Tytus Kurek from Canonical Group Limited, and Eriksson from the Arctos Labs Scandinavia. All have been deeply involved in the activity, and hence they're very well qualified to give this webinar. Before I hand over to the speakers, I'd like to remind you of some quick points about the webinar. A recording of this webinar will be available on demand a few minutes after we've ended it at the same location as to where you are right now. Feel free to ask questions at any time by clicking on the Ask a Question button. We will handle the questions at the end of the webinar, and if we don't answer your question or don't get time, don't worry, we'll get back to you after the webinar by email. We've also attached the slides in the PDF form and other useful information, and you can download them from the Attachments button. You can also share this webinar using the social media buttons above the viewer and rate it with the Rate This button. Now over to our presenters, and first of all I will hand over to Gerardo Garcia.
Thank you, Gavin. So just let's recap from what you saw yesterday in the webinar. Yesterday you got an idea of what came with OSM Release 7, the main highlights from an introduction from Francisco Javier. Then you get an idea of the different features that are available in OSM with a very complete demo from Gian Pietro. And finally, you get an idea on the way to monitor the whole OSM platform that was provided by Francisco. Today, we are going to focus on two interesting features that come with Release 7, that are mainly the capability to run cloud-native applications, mainly Kubernetes application with OSM. And in addition, you will get also an idea of a new feature that is coming, that is the automatic placement of network service, a feature that allows you to determine the better placement for VNFs in order to meet some constraints. Okay, I will give my presentation will focus on the general view on Kubernetes with OSM. I will show you some demos, and then Tytus will proceed with some updates on that, and finally Mats on the automatic placement. Okay. Just a reminder, as we also mentioned yesterday, is that if you want to learn more and get an idea of what's coming with next release, and you want to learn more about OSM, you can register to the next OSM Hackfest that will take place in Madrid in the week of 9 to the 13th of March. So now let's start. So why we have decided to include the cage support in OSM? Well, I think that there are three main reasons. We will also probably in this session. Is that first of all, a lot of applications are based today in microservices. It's the common trend today for any IT application, and well, in fact, OSM is also running in microservices. It can, in previous releases, it was possible to run it with Docker Swarm, but now in this release, we are able to run OSM not only with Docker Swarm, but also on a Kubernetes cluster, okay? And in fact, well, this is one of the options that we have in the community installer. And I must say that all the distros in OSM have decided to use Kubernetes as the platform to deploy OSM. The next reason is that most of the new NFV use cases for 5G core or universal CPE, SD-WAN use cases are also based on Kubernetes. And finally, the last reason is that most of the edge use cases that are related to the creation of dedicated containers and microservices for attending a specific request, okay, for the end users. In the case of the edge, are based mostly on Kubernetes. So those are the main three reasons that we think that are driving us to implement the case support in OSM. So let me introduce, for those that are not maybe fully aware of what's a case application, but a case application mainly requires two things, okay, and that's what we need to provide from OSM somehow. One is a case cluster. Obviously, a case application requires a set of nodes that are a case cluster, and the case cluster is mainly, well, a set of nodes with typically one or several master nodes that are offering an API, and other nodes that are the ones running actually the workloads. Okay. The case clusters can be created in very different ways. They can be well created with standalone platforms like OpenShift or Chunk Case from Canonical, or, well, there are lots of vendors also offering their solutions, or they could be created as part of a VM. The VM could offer a capability to create a case cluster. That's the case, for instance, of VMware Cloud PKS, or AWS also offers a way to create your own cluster so that you could use them. Okay. Then, second thing that it's interesting for you to know, maybe you are not aware of this, but a case cluster can run on bare metal nodes or on VMs. In fact, for instance, the virtual machines are the option offered by default by Google when you are using one of their clusters. Okay, so if you want to use one cluster, the clusters are based mainly on VMs. Okay, but in all the cases, no matter the way it was created, each cluster provides the case API that it's the same. Okay. You also need to take into account, you need to know that there could be different versions of Kubernetes, mainly different versions of the software that is, let's say, controlling the platform, etc., and offering the API. There could be different versions of that, and different plugins for networking, what it's called the CNI plugins. Okay. And, well, some applications might require to use specific objects that are available in some specific versions of Kubernetes. And also it might happen that some versions should rely on some specific networking features that could be available on some plugins or not. Okay. So that's all about the case cluster. Now, the second requirement from the case applications are the case service objects. So mainly an application needs to, or a vendor offering an application, a case application needs to write or some service objects. Okay, those service objects are provided by the Kubernetes API. So the API is offering a huge number of high-level service objects that are mainly the core of its functionality. Okay, and those are the ones that the developers need to create in order to deploy a case application over case. Okay, and here we are describing some of them: the pod sets, or what we call pod sets, right? Deployments, stateful sets, the services to expose the applications, and well, the storage, different kind of stuff. And there are others, okay, other objects like config maps, secrets, etc. But in order to use them properly, there are two ways that have appeared in the industry to package the different definitions of those service objects into a package format that allows you to manage the whole application with a single file, right? Typically, the two main ways are the Helm charts and the Juju charms or Juju bundles. Okay, in both cases, in the end, it's just a compilation of the different manifest files. Well, in the case of Juju, with some tweaking, okay, but and in the end, there are some indirect calls to the Kate API, either through Helm or through Juju. Okay, so in the end, in both cases, we are the solutions are interfacing directly with the Kubernetes API offered by the Kubernetes cluster. Okay. Well, so once we have understood what an application needs, okay, well, this is an animation of what you will get. Okay, when you deploy, you will get a lot of deployments, etc. Okay, so how we have managed or we have foreseen and designed and implemented the support of Kubernetes in OSM. So first of all, and this is key in OSM, is that we wanted the Kate application to be modeled through the descriptor, so that everything should be model driven, like everything in OSM. So descriptors and information model are key here. So whenever we introduce a new functionality, we identify the changes to be done in the information model. And in this case, the way we have decided is by creating a new kind of deployment unit. So typically a network function, an NF that is specified, whose composition is specified in the descriptor, can consist of different deployment units. They could be virtual, physical, or a Kubernetes application, or a mix of them. So we could have a pure virtual network function with only virtual deployment units or virtual machines, okay? We could have a pure physical network function consisting of a single PDU or a set of PDUs. We could have a pure Kubernetes application with what we call a KDU. That's the new concept that has been added in our information model. Or we could have hybrid network functions consisting, for instance, of a mixture of KDUs and VDUs, or a mixture of VDUs and PDUs, etc. Okay, and there are two main portions of the descriptor that need to be declared for any Kate application. First of all, is that for each KDU we need to specify the Helm chart or Juju bundle that is used to package that application, and we need to include that in the descriptor. And the second thing that we need to include is the set of cluster requirements that this specific Kate application might impose, like as I mentioned before, the version of Kubernetes or the specific CNA plugins that might be required, or for instance the number of networks that are required. Because, for instance, that application requires that some services are exposed in a different network than others. Okay. Well, so I think that we get more or less the picture. Then the second decision is that obviously for any Kubernetes application or KDU in this case, for every deployment units that is based on case, we need a cluster, okay, to be created. And here we could make OSM prepare develop the whole cycle, let's say. So OSM could create a Kubernetes cluster, and then we could use that cluster to deploy the KDU. the point is the following: that there are many ways to create a cluster. So, and we need to agree on the fact that there are already existing ways to create a cluster. So we don't want to reinvent the wheel. So different options for creating the cluster are, for instance, there could be an external platform that like well, some of the ones that we have mentioned before, okay, that could create the Kubernetes cluster for you. Okay, in that case, obviously, OSM won't create it. OSM just needs to know that the cluster exists and that we want to use it. Okay, there could be also well, APIs that could be attacked for creating a cluster. So well, there are some platforms like OpenShift or well, any others, AWS or others, that you could, VMware PKS, that you could interface to create a Kubernetes cluster. And in that situation, we have foreseen that OSM could be working or helping in that cluster creation. Okay. Well, that's something that we have foreseen that could be interesting. In other cases, that in some cases we even might create a Kubernetes cluster with a regular network service. So OSM itself can be used to create a cluster. So as you can see here, there are lots of options. Okay, but what all of them have in common is that no matter the way the cluster has been created, in the end we have a cluster that we want to use, and we need to tell OSM that this cluster exists so that they could use it. Okay, and finally, the catalog of, well, the use of the cluster. Okay, the use of the cluster is clear. This has been the focus of this release. OSM Release 7 is focused on deploying the applications on a Kubernetes cluster. The cluster is assumed to exist, okay, and we would use it. And the well, with the incorporation of both Helm charts and Juju bundles, we are providing, we think, a future-proof way to deploy applications. We are seeing that it's a common trend to package applications in those formats that are providing even today more than 20,000 stable applications that are available for production. Okay, so finally, well, we have seen the different steps when deploying an application. We need a cluster, and then we need to use it to deploy the different service objects that are modeling that KNF. And we need to understand the different the lifecycle management of the KDUs, and this is what also has been included in this Release 7. The Release 7 includes today this main 4 lifecycle operations that are the installation of a K application or the deployment, let's say, the upgrade to use new versions of the Helm charts or the Juju bundles, or an upgrade of the configuration. Also the rollback, that is mainly to roll back to a previous version that was already installed, and the deletion or removal of the deployment. Okay, all of them have been developed in this Release 7 and will be shown in the demo that I will show right now. Okay, now it's demo time. Okay, so I hope that you could follow, hopefully, the demo. There are 3 demos, and hopefully you will get an idea on the different aspects. First of all, I will show you a cluster creation using an OSM network service. Then I will use that cluster to deploy a simple case network function. And finally, I will deploy a more complex network function on top of that OSM. So I will share my screen now. Okay. Well, so the first demo is the cluster creation using OSM network service. So this is not something that came with release 7. With the release 6, you could create a network service package that could deploy a Kubernetes cluster, and that's what we have done. And we are using that in order to illustrate the cluster creation. So, well, let me. I will use the OSM command line to illustrate the way it works. Okay. So first of all, you need some packages. Okay. And well, here I have different packages. I have 3 different packages. One that will be used for modeling the cage machine, Kubernetes master or Kubernetes node, it doesn't matter. Then a second VNF package that contains the installer or a typical installer that you could find. There are lots of installers available. You could use an installer based on Juju or Kubespy or other installers that exist today to create a multi-node cluster. Okay, and finally a network service package that is combining all of them. Okay. So in the end, just so that you could get a picture, I will show you the network service descriptor that has been used. Okay, in this network service descriptor, you will see that well, there are 5 different VNFs. VNFs 1, 2, 3, and 4 are mainly the cage machines that will become master or nodes. And the other one is what we have called the Juju controller, because in this case the installer is based on Juju, but if there are other VNFs that are using it, it would be okay. And all of them are connected to a single network. Okay, so this process I will show you how to deploy a Kubernetes cluster. It's as easy as this. This line here is just create an instance of OSM whose name will be cage cluster 1. It will be based on the network service that I have showed you before. It will be deployed in a specific bin. That means that we are going to use VMs for the nodes, obviously, and that's the way we are going to do. We are passing some parameters, okay, that are required in this case for the configuration, etc. And finally, an SSH key so that we could access to the different components of the deployment. Oh, sorry about that. I'm not located in the right folder. That will show you that it's real, okay? Okay, done. And now you will see here that a new network service is being created, okay? This could take a lot of time, like 45 minutes or so. So in order to make things quicker so that we could make the session profitable, we have created 2 other clusters, clusters 2 and cluster 3, that are let's say in different degrees of deployment. The cluster 1 has just been launched. A cluster 2, similar to cluster 1, is right now in this position here. So we will see that the cluster is being created, and the cluster 3 is already created, and that's the one that we will use for the next demos. Okay. So if we go to cluster 2, I will connect to the cluster 2 here. Sorry. Okay, I'm going to make the cluster 2 progress. Okay, and now let's see here what's happening. Okay, in the cluster 2. So you see here that in cluster 2 there are already 4 machines that are there, and we will see that things start to appear right now, and the different let's say, components of the cluster are being deployed. Okay, we'll see in some minutes. And this is the final cluster that we will use. And once the cluster is ready, we will have a full cluster, okay, containing Flannel, etcd, the Kubernetes master, the Kubernetes worker, the load balancer. In this case, as I mentioned before, we are using Juju as installer, but if you use the QSpray and you create a package for modeling that installation, that also would be possible, okay? Okay, here you see that the applications are being launched, container B in this case is being deployed, is here RSA, etcd, Flannel, and in the end, we'll get a cluster like cluster 3 with everything ready. Okay, so those packages will be available so that we will provide this as part of the things that we are providing for free in OSM, so that you could use them, okay, those packages to create your own cluster if you want. Okay, here you see that the things are progressing right now, and after some time we will get into this position. So that's the first demo. Okay. We had also the second demo is the deployment of a cage application. Okay, we will see a very simple application and we will deploy it. Let me show you the application. Oh, it's here. The application is Open LDAP. It's pretty simple. Okay, you know that. Okay, it's on Open LDAP. LDAP is probably one of the simplest applications. Let's see the descriptor of the Open LDAP. Pretty simple, right? An Open LDAP is mainly a network function consisting of a single KDU that is called LDAP. And in this case, this LDAP is based on a Helm chart that comes from the stable repo of Helm charts. And it's the Open LDAP Helm chart with version 1.2.1. Okay, and it imposes a requirement in the cage cluster, not specifically a version at all, but it requests us to have a Kubernetes cluster with a single network. Okay, well, pretty simple. The network service, more or less, pretty simple. Okay, it's more or less the same. Okay, it's just the network service is just the VNF that we have mentioned before, the KNF in this case, Open LDAP connected to that network. Okay, so now let me show you how to deploy it in OSM. Okay, I will go to here. So first of all, what do we need? We need to tell OSM about the cluster. Right now there are no clusters in OSM. Okay, I'm going to add it. Okay, I'm going to allow the connection to the cluster, because otherwise we won't be able to connect. And now I'm connecting. I'm going to add the cluster. And we could see that the cluster has been added. Okay, you see here that the operational state is processing, because some minor operations are required to be done in the cluster. For instance, in the case of Helm, we need the Helm charts. We need to initialize the cluster to be able to run Helm charts, and the same for the Juju bundles. We need to initialize it in order to be able to run later on Juju charts on there. Okay. Well, after some time, we expect it to be there, processing, and well, meanwhile, I will add the different packages. Adding a network function package is as simple as this. Okay, and the same for the network service. Now let me check the status of the cluster, because it's still processing. I want to make sure that it works, okay, because otherwise we'll have some issues, okay. And Okay. I think it's there, so we can probably progress. Okay. Let me deploy the network service. Okay, the network service is pretty simple. Okay, I'm again doing a network service create of the network service LDAP. That's the name of the network service that I will use based on the network service package that I have added before, and I will deploy it in that bin. So this is the way OSM works. It will take the information here. It will know it will identify what clusters have been added in that bin. So it will identify that the cluster 3 has been is part of this connected to that bin, and will select it to deploy the application. Okay. Okay, it's being deployed. Okay, let me show you. Whenever it's, I will show you that the package is created, that the instance is deployed. Taking some time, still there. Now, okay. Okay, now it's going well. Finally. Well, it typically takes a few seconds to deploy an application, and well, but in this case it seems that the initialization of the cluster took some time, and that's the reason. Okay, I will show you later on that a new application goes quick. Okay, now let's check here. It's been deployed, done. Let's check the network services associated with that. Okay. Okay, this is the network service, the network function. Sorry, let's check the status of the specific so here KDU LDAP. Oh, the specific KDU LDAP. Okay, here we can see, for instance, that all the details of that specific LDAP Kubernetes application, the way to access to it, and the different resources that have been created, the config map, the pod, the secret, the service, and the deployment. And once it's ready, we could do a lot of things with that. We could upgrade the LDAP platform or the LDAP application to use a new version. For instance, open LDAP 1.2.2. Okay, it's as simple as one command action over the network service LDAP to upgrade it to this new version. And if we check here, we see that right now there is a revision, that is revision 1, that is based on OpenLDAP 1.2.1, and in 1 minute or so we will have that we will see that there is a new revision. Okay, that it's there. Get all. We are seeing that there is a new replica set that is being created, new pods that are being created, and in a few seconds we will have the new revision there. Revision 2 based on OpenLDAP 1.2.2. We could even increase the number of replicas, okay, of that one, like this. We want to use the version 1.2.2 and 2 replicas, okay. Let's see here. there is a new deployment here. You see here that there is 1 out of 2. So the number of replicas of this has been increased. Okay. And very shortly we will have it already there with the revision 3 of the application. Revision 3, and now with the 2 replicas. Okay, we get all the details. We see here the 2 replicas and the two pods here. Okay, and well, besides that, we could do a rollback. Obviously, that's the next thing that we can do is a rollback. That will roll back to the previous case where we have a single replica. Okay, this should be more or less straightforward, I guess. Revision 4. And if we see here, we can see probably the number of replicas. Okay, that it's only 1. Okay, 1 deployment with 1 out of 1 and 1 single pod here. Okay, and obviously we could also delete it. Delete the application. That's all. Oh, sorry, I will do it in OSM. Well, it's not here, and hopefully the application is not running here. And if we check here what it's running in the OSM workspace, nothing is there. So well, you can see here that from OSM Urban Interface, it's very easy to control the whole life cycle. We could deploy, we could upgrade a specific KDU, rollback of a specific KDU, and delete the network service. Okay, and that will also, everything will be managed through the northbound interface of OSM, either through the client or through the graphical interface. Okay, and finally the demo 3, and well, since there is not too much time, I won't spend too much time on that. Is that it's possible to model very complex application. Okay, here in this case we have modeled a typical big data application. I will show you here. Demo 3, fast data KNF. This application could consist of an IFI for ingesting the different data, Kafka to get the data and distribute it. It could consist of a Spark, but right now has been removed because we are working on it to make it fully working. And we could also have Elastic Data, Elastic Master, Kibana, and all of that is modeled with a single descriptor like this, okay, and deployed with with a network service, pretty more or less simple, okay, just like this, okay, and well, it's as easy as just onboarding those packages and deploying them, and in minutes we have a full big data application deployed with OSM, okay. And well, that's all from my side. I will pass the turn right now to Tytus. Okay, I will. You can take the lead, Tytus. Now I'll continue with the slides. Okay.
Thank you, Gerardo. That was a great introduction to the cloud native network services. So before we move to the next part, which is about deploying container network functions on Kubernetes with OSM and K-charms, let me briefly introduce myself. So my name is Tytus Kurek. I'm a product manager at Canonical for Charmed OSM, which is one of the available OSM distributions. And this feature that I'm going to demonstrate has been contributed to release 7 by Canonical team, as we're a member of the OSM community. So some of those slides are going to overlap with what Gerardo has already presented. So I'll go quickly through them and move to the demo, as this is the most interesting part, I think. So just to clarify, as we're struggling with various types of network functions nowadays, so let's have a quick look on what's available and what's going to come in the nearby future. So we obviously have virtual network functions. This is where the journey started. So they have been with us for a while. Those are running inside of virtual machines provided by cloud platforms like OpenStack or any of the available public clouds. We have physical network functions, which are running on top of bare metal machines, which are usually managed by some infrastructure provisioning tools like MAS or Ironic. At the moment, OSM does not provide support for this kind of plugins, but features like that may come in the nearby future. And we have container network functions, which are running inside of containers being managed by some container orchestration platforms like Kubernetes. And obviously, we have hybrid network functions, which can run on top of any of those, and the whole network service can be distributed across various types of the underlying machines. So just to summarize, why CNFs? Why do we want to focus on container network functions, and why are telecommunication service providers moving towards container network functions? So the key motivation behind CNFs is the microservices architecture, which is one of the key requirements of 5G. So historically, telecommunication service providers used to migrate their legacy monolithic services directly to cloud environments. And this approach obviously worked, but was creating a lot of issues. So at some point, they realized that for 5G, network services have to be fully redesigned based on the microservices architecture to make sure that they are cloud native. And as containers fit perfectly into microservices architectures, they are a native solution. They are a native way to move forward. So that's one motivation behind CNFs, but obviously performance and density considerations play an important role. Containers run at bare metal-like performance, and the image size is usually much smaller compared to the virtual machines. So this is especially important in the case of the edge deployment, where the hardware resources of the edge devices are much more limited compared to those running in big data centers in the cloud. So containers fit much better for edge than traditional virtual machines. Also, more complex network services play an important role. So at the beginning, we had just a few use cases of DNFs, but they have evolved, and we have more, and also network services are becoming more and more complex. So containers, again, fit much better. And container platforms like Kubernetes provide better orchestration capabilities than regular cloud platforms. So features like auto-scaling or rolling updates are usually better supported by Kubernetes than OpenStack, for example. But a successful deployment of container network functions is just the beginning of the journey. Those have to be operated post-deployment, and this is where day one and day two configuration comes in. Fortunately, Kubernetes provides a software extension which are called operators that make use of custom resources to manage applications and their components. And if we have a look at the following picture, what we can see is that together with the application pod being deployed, there's an operator pod being deployed. So the application pod basically runs the application software, while the operator pod runs the operator software. And operators abstract operational complexity, abstract operational tasks in a form of primitives. So these primitives can be something like install, scale up, upgrade, change configuration, stop the service, start the service. And the only thing the end user has to care about is to execute those primitives. And operators take care of the rest, take care of executing the actual set of instructions on the application software. So operators abstract operational complexity, but they do not define how to implement the actual operator software. And fortunately, there is something called Kubernetes charms. And we know charms in the OSM community very well because they have been used since the very early beginning. Charms basically contain the entire logic required to perform day 1 and day 2 operations, such as connecting network functions inside of network services. They implement network functions primitives, such as this install, scale up, and upgrade, and they provide configuration management capabilities. And by using the concept of relations, hooks, actions, and templates, charms provide a native framework for implementing the operator software. They are operators. They act as Kubernetes operators. So now in the following part, we're going to see how charms are being used to deploy container network functions on top of Kubernetes. And just to briefly explain this process, so we start with Kubernetes itself. It obviously provides containers. And on top of these Kubernetes, we install OSM. So the OSM services are run inside of some of those containers provided by Kubernetes. And then OSM can use exactly the same Kubernetes to deploy container network functions. So at the end, some of those containers will be used by the OSM services, while the others will be used to serve the operator and application pods for the container network functions being deployed. How to do it in practice? So inside of the VNF descriptor, there is a KDU session which now has, starting from OSM release 7, a Juju bundle parameter where we can specify any Juju bundle that we're going to deploy on top of Kubernetes. And the Juju bundle is basically a definition of the Juju model. It contains a list of applications being deployed, a number of application units, their configuration options, relations between them. It is a definition of the ultimate state of the environment that we are going to deploy. And for the purpose of the demo today, we're going to use a basic MediaWiki bundle, which contains 2 applications, MediaWiki for serving the actual service, and MariaDB, which is a database that MediaWiki uses to store the data. And moving towards the demo part, I'm going to share my screen now. So this is my demo environment that I'm going to use. So let's have a look first on what do I have installed here. So I have MicroK installed, and MicroK is a minimal Kubernetes cluster that is installed through Snap. And this is what I'm going to use to deploy my container network functions on top of it. And I have the upstream OSM version 7 installed. So this is running on a separate container orchestration platform as the upstream installer provides. And I have an AWS Vim configured here, as this whole environment is running on AWS, but it is not really being used, so it is required to have Vim added to OSM and configured prior to creating K8s cluster, but it is not really being used. Like everything gets deployed directly on top of MicroK8s. So we can obviously take a look on some configuration options of this Vim. And the other thing I have already installed here and configured is the K8s cluster. So this is my microK8s Kubernetes cluster. We can also have a look on some details. Right, and I have an VNF package that has this Juju bundle defined inside of the VNF descriptor. So let's have a look on it. Right, so this is exactly what you could see at the presentation. So there is a KVU section which has a Juju bundle parameter which points to one of the available Juju bundles at the Charm store. In this case, it's a MediaWiki bundle. And these packages, like these two packages, have already been uploaded to my OSM installation. So we can have a look on a list of the available packages. And what I'm going to do right now is to deploy a network service from these packages. So at the moment, a list of network services is empty. And I'm going to use some very long commands, which I wrote down previously, because it's pretty complex. I didn't want to make a mistake. So it creates a network service. It uses those with an HFK name. It uses those packages that have been previously uploaded. We have to specify a Vim, although it's not really being used, and some parameters with regards to networking of the Vim. And as we can see, it's deploying. We can run this command in a loop to have a look when it gets deployed, because it takes a while. So let's wait until it gets deployed. For some reason, it's taking longer than I expected, so we'll get back to this comment in a second. What we should be able to see later on is that so we can list the Docker images running on the machine that I'm using for demo purposes, and there is an LCM container here where the actual Juju controller for my network service being deployed should be created. So I should be able to execute a command inside of this container to switch to my to a controller, to a model representing representing the actual network service being deployed. So let's have a look on the list of network services again. Still deploying. So we can get back to that in a second. In meantime, I'll take a look on some other cluster that has already this network service deployed. So here is exactly what you should be able to see. So there's a network service with configured and done state. Here it's still deploying, right? And same story. So Docker exec the ID of the LCM container. We switch to the model that has the name of the network service, the ID of the network service, and we can run Juju status here. inside of this model. And we see the MariaDB and MediaWiki applications being deployed in the active state. And now with microcates, kubectl get pods under the namespace of the same name as the network service name. We should be able to see 4 pods being created, while 2 of them would be the application pods and the other 2 would be the operator pods. So this one is still deploying. We can get back to that later on. But that's basically end of the demo. So this is what you should be able to see. So with each of the application pod being deployed, there should be an operator pod being deployed that is responsible for performing day 1 and day 2 configuration of our deployed container network functions. So that's actually end of the demo. So at this point, I think I'm going to hand the microphone to Matt.
Yeah, thank you, Tytus. And now we're going into the third part of this webinar, which is about placement optimization in OSM. My name is Matt Eriksson. I'm the CEO of Arctos Labs Scandinavia, and we are a software service provider to the telco industry. So this is something we have contributed to OSM. So I'll walk you through, and then there will be a demo. So basically, I'm trying to go forward on the slides here. Seems it doesn't work. Yeah, now. I did too, sorry. So basically, I will go through what we mean by placement and introducing optimization and how you can use this feature to achieve different types of optimization and some use cases, and how we invoke that from the northbound interface, and then a demonstration. Before we go further, this is a feature that is available from release 7.1. So if you're running the upstream 7.0, this feature is not currently available, but it's coming soon. I assume you will ask the questions on when, which I divert to Gerardo and other guys. So what you will see in the demo is kind of running the working version of 7.1. So what do we mean by placement? It's basically where does different VNFs end up within an NSD in a distributed data center environment. So for example, we may have a central data center, a regional, and a couple of local ones. So which VNF goes where, basically. And optimal then is subject to, for example, the cost of compute in the different data centers, which might be different, the cost of links or transport capacity for interworking between the VNFs should they become distributed, and also do we have any constraints on that interworking, for example, latency or jitter, in case there are constraints on that, which might limit the possible ways this can be distributed. The feature here makes this placement, there's kind of 2 things. One is that it becomes automatic. So the OSM will automatically calculate where to put the different VNFs. And furthermore, it becomes optimal. And optimal here means cost optimal. So it basically works like this, that there is input to this optimization process. So there is we need to give, of course, the VNF and the NSD, and we need to specify if there are any constraints on the links, the way the different VNFs are interconnected, and we need to give an input which on the cost of links and compute. This cost input is kind of there. It's a configuration file that you give to OSM. And then once you have that, and then the optimization criteria is about cost. To achieve the link constraints on the most cost optimal way. So that is what the feature will do, basically. So what we have done is we've introduced a new module called PLA into OSM, and it's basically, so you use the normal instantiation, northbound interface or GUI to invoke instantiation. You give whatever constraints you want to apply, if there are any, as parameters, and the optimization engine uses the configuration file where the description of the infrastructure or parameters of the infrastructure is defined. So it will consider placement over the VIMs that is available to the user. So some users may not have access to all VIMs, so it will take that into account. And of course, we can think about a number of different examples of how optimization could work. So the first thing is we don't give anything as a constraint input, then it will be a cost optimization only. So try to put it where it's cheapest, basically. But the key point is that it considers both the transport aspects as well as the compute costs. The second thing, of course, is we give some constraint. Then it would be cost optimization taking latency constraints in this example into account. We can think into the future a little bit. So this is not things that will be in 7.1, but it's kind of imaginable extensions. So for example, maybe we want to optimize utilization rather than cost, spread loads in a particular way between the different data centers. Or we may want to consider certain capabilities like specific compute types or things like that. So this is a start of a journey, we think, about how OSM can support different optimizations. So if we think about use cases, so for example, we may need to deploy a UPF function in a particular place to support low latency. So that will be an example of a constraint. So it needs to be close to the customer, kind of the edge use cases. We may have certain application components, kind of over-the-top applications like IoT, data processing, things that we want to deploy somewhere because we want to do an aggregation and a data processing before sending data onwards and save transport capacity in our network. Or we may want to reduce the compute cost for slicing. For example, we have an EPC network for a particular network slice, and we can deploy certain of those components in a more central and more cost-efficient location, whilst others need to be closer to customers, for example. This is just a couple of examples of use cases. So we can think of how we do this from the northbound interface. Now this is a bit work ongoing, so the details here might change slightly. So we can give parameters that will request cost placement optimization only, or we can add certain more parameters that would tell the engine that one of the VNFs needs to go in a particular VIN. So we call that pinning. So whilst the other VNFs could be placed optimally, or we could say that we want to have a placement where we give certain link constraints like latency and jitter on particular links, and of course we can combine 2 and 3. So we want to pin and we want to have latency constraints or something like that. So these are 4 different ways by which we can invoke this. Now I'm waiting for the... Oops, I don't know why this doesn't change my slides. Sorry for this. I'm pressing again. I'll probably... So this is just to give an example of this pinning feature, that we can give a certain Vim identifier for a certain VNF and let the other ones be automatic, and it could be either permutation of that, and that of course be used if we know that we want to have a certain VNF in a Vim where we have another VNF, for example, a packet gateway, or we have another PNF that has an endpoint somewhere, or it's a customer location, so we want to pin them accordingly. And here auto means there is no Vim specified, so the engine, the optimization engine, will calculate the most optimal placement of that one. And of course, this is a new feature. We would love to have feedback on what you think, and we want to assist in your projects. So don't hesitate to contact us and see how we can support and for questions or something. And then I would go over to a demo where this would be seen. Just give me a sec. So I hope you can see my screen. So basically what you see here is the outlook of the demo. You have a map. We've selected Spain, and we have 4 data centers that are interconnected. They have numbers, identifiers, and you can see, you can see certain data about the links, properties of the links. You have the dashboard, and there is the CLI of OSM. Before we go into the actual demo, I want to show you the cost and infrastructure model that applies to this demo. So we have cost of compute in 2 of the VIMs is 50. It's 20 in Vim number 2, and it's 10 in Vim number 1. And you see the figures of cost and latency for interconnectivity between the different VIMs. So this is the input to the placement engine in this particular demonstration. Secondly, this is what I will run as a demo. So I will run 3 scenarios, where the first one have completely automatic and optimized placement, where the engine calculates where to put the VNFs. Scenario B, we use a pinning to one of the VIMs, and scenario C, we use pinning and latency. And the NSD in all 3 cases is the same. It's 3 VNFs and 2 VLDs interconnecting these 2. So now, let me just... so the first thing then is scenario A, and we just tell the engine, tell the placement engine, or the OSM, that we want to have placement done, and we trigger that. And now you'll see on the visualization here that all 3 VNFs ended up in data center number 1, and this obviously is because that data center has the lowest cost for compute. So that's a cost optimization, and we didn't give any other constraints on where to put it, basically. Just wait for a little bit so it gets ready. I think we could, oops. Something is wrong with my... sorry. And now, let's see, I can then quickly just make a list of the VNFs that I have for this service, and you can see on the Vim account IDs, they all run on the same Vim account. And so if we now run scenario B, that would be saying that we want to have a particular the VNF number 1 we want to have in OpenStack number 3. So we specify that, and we initialize this, and then we would see now we've pinned this to number 3. So one of the VNFs, VNF number 1, will end up here. The 2 others will end up there. And that's because we didn't have any other constraints on those 2 VNFs. And you can also see here in the illustration the total cost of the deployment, basically. And we could then also list the VNFs that we have there, and you will see. Oh, there's something wrong with my illustration. But you will see that they end up in different limbs. These 3 VNFs. And then.
Matt, I'm under the impression, Matt, that you are not sharing your screen right now.
Aha.
Sorry to interrupt you.
Yeah. Oh, well, okay. So then I'll need to go back. What happened then? I'm resharing. See? Do you see my screen now?
Yes, perfect.
Oh, okay. Sorry for this. Sorry. So I don't know what you missed. I hope you notified me immediately. So basically, we've been running scenario B, where we pinned one of the VNFs to a particular location, and ended up with the other ones being freely placed. And then the last scenario that I'm going to show is where we say we want to pin this one of the VNFs to location 4. And we specify a latency constraints between VNF 1 and VNF 2, basically. And then we kick that one off, and it initializes, and it basically means that we said scenario VNF 1 should be in location 4, and we need a 5 millisecond latency to the next VNF, which means that VNF has to be in the same location, whilst the engine now have to choose between whether to put it in the third VNF, to put it in location 1 or location 2, and it selects location 2 because of that the total sum of transport and compute is lower for that location compared with putting it in in location number 1, which ended up with a 40 compared with 30. So it basically do cost optimization for the last VNF, ending up with this deployment that you see here on the map. And we can then also just make a list of the VNFs that we have and see that 2 of them are in location 4 and 1 of them are in location 2, basically. So with this, I've concluded my my demonstration, and again, thank you, and get back to Gavin, I guess, for questions and answers.
Okay, thank you very much. Looking at the questions, we have a number, and so we can start with some of these and see how we can go. The first one on the list I've got is to define and describe a KDU in a VNFD is referencing to a Helm chart the only option? Is OSM adding some feature on top of Helm? And is OSM in this case a kind of wrapper of the Helm?
Yeah, thank you, Gavin. Yeah, just before answering the questions, let me just remind you that there is a Hackfest in the week of 9 of March in Madrid. Okay, and this Hackfest is free of cost, and seats are limited, so the sooner you register, the better. Okay, so if you want to learn more about cloud native engines or any other features in OSM, please join. So answering the question, well, I think that it was partially answered. OSM supports two ways to describe a Kubernetes application, or what we call a Kubernetes deployment unit. It's through a Helm chart or through a Juju bundle. But besides that, OSM also adds all the capabilities of day one and day two operations through charms, and the capability to integrate with those K8s applications with virtual machines or physical nodes in hybrid network functions, and improve networking if needed in order to expose the K8s applications potentially in different networks. Okay, and well, all of this combined with the high-level features offered by OSM, like the use of slices, the unified monitoring. In general, I would say that OSM is a universal platform for the orchestration of both IT and network applications, accepting multiple formats. Okay, I think that would answer more or less your question. I don't know if Tytus or Mats want to add anything.
No, I think you explained that pretty well.
Okay, there are several questions that are referring to the same topic, so I would like to answer them before we move on to the next ones. Is that there are lots of questions asking about OSM helping to create the Kubernetes cluster. Okay, and I think that maybe there could be some misunderstanding from the demo, etc. Let me make it explicit. The K8s cluster creation is not part of OSM Release 7. Release 7 is mainly using an already existing cluster. And the plan is that we want Release 8 to deal with the cluster creation that could be done in different ways, either interfacing with a Vim, using the Vim API, interfacing with a Kubernetes platform directly like OpenShift, or even creating the cluster directly from OSM, okay, in a specific Vim, but not using a Vim API, but making OSM deploying there the cluster, okay. What we have shown in the demo today is a way to deploy a K8s cluster using an OSM network service package, okay, and it's a way that it could have been done from previous releases, just making use of the tooling that OSM is providing, okay, and those packages that we have shown here in the demo will be made available and properly documented, so that you could create the cluster on your own if you want, okay. So now let's move to the next question.
Okay. The way of implementation of the K8 cluster is not mentioned in the documentation. I saw a comment saying that perhaps this is correct.
Yes, it's correct. The way of creating a cluster, the one that we have shown here in the demo, the way to create a cluster with OSM, is not covered in the actual documentation of the Release 7. We will take into account the comment, okay?
Okay. Another gentleman has been saying that he's tried to add the K8 cluster many times and has shared the problems faced in the Slack application, and asked what is the recommended way to raise similar issues.
Yeah, so this is well, for those that are not aware, we have in OSM, we use Slack. Slack is a platform for like IRC 3.0, we could say, okay, it's a platform to relate all the community, answer any question, and well, even the daily work of developers and model leads is done through Slack. And yes, this issue that was raised in Slack, I'm not sure if I know the exact issue. I would like if you could be more precise. It would be great, because there are lots of questions and I'm not sure on the one that you are actually mentioning. But just in case it helps, the typical issues that we have faced with the case cluster usage is that OSM needs to have connectivity to the cluster, otherwise there will be issues. And sometimes you are creating cluster using other tools that you are not providing the connectivity. And in other cases, the case cluster requires typically open EBS or any other containerized storage, block storage framework to deal with persistent volume claims, which are required for most of the applications. So that could be also the issue. Anyway, if you could be more precise, or if you want, you can reach me directly in Slack if you have a specific question on that. Okay.
Okay. The next, somebody else wish to say anything?
Any Tytus or Matt? Or Matt? No. Okay.
No. Someone was also asking if we could give in more detail the advantages of managing K8s-based applications through OSM versus K8s or OpenShift.
Yeah, I think that I mentioned before, right? The capability to have day one and day two operations, the capability to integrate the K8s application with VMs or physical nodes, the improved networking that could be done with OSM, and everything combined in a single platform. Okay, that I think that these are the main advantages.
Okay, there's a further question about the time frame for release 7.1 and release 8. So I think I recalled yesterday somebody saying, well, there could be something fairly quickly, but I'll leave that to you.
Well, yes. Release 8 will come, typically is coming 6 months after the previous release. So taking into account that release 7 was on December 2019, it will arrive on June, probably this year. Okay. And can you hear me well? Yes, right? Okay.
Okay.
The release 7.1, I think, well, we use here what it's called or known as semantic versioning. So typically, for any bug fixings, we will release 7.0.1, .2, .3, etc. Okay, for the bug fixing, and we will use 7.1 for the release adding a substantial change. For instance, the placement is something that is a substantial change because it's something new, and we will probably launch a 7.1 release that could happen on February or March at any moment in time between this release in this release cycle. Okay.
Okay. There's a couple now. One is whether they can create K8 cluster by NS, and it is available today in release 7. And then another one saying they've tested in release 7. The only available option to add K8 cluster is through a Vim and Vim network, and can they manage the K8 cluster alone?
Yes, I would say that first of all, OSM is expected to build networks of network functions. So a cluster alone is something that does not have a lot of sense. But apart from that, okay, apart from that fact that it's something that might not make sense, you need a Vim because the Vim is the only way to indicate a target location for a network function when you are deploying. So whenever you whenever you add a cluster to OSM, okay, you let OSM know about the cluster, you have to indicate a Vim, and when you are doing that, you are creating an association between the Vim and the cluster, but nothing special is done on the Vim. So the way to, let's say, work around for this is that you could create a fake Vim, okay, or the person asking for that could create a fake Vim and associate the cluster to that fake Vim. Anyway, if you have any questions, you could reach us also in Slack, okay, if you face any issues with this cluster creation, okay?
Okay, there's some questions that have come in quite recently. The first one, is a Juju controller needed on the remote Kates cluster to integrate it in OSM?
So let me take this one. So yes, when using Kubernetes charms for CNF deployment, the Juju controller is needed on the remote Kates cluster, but it is bootstrapped automatically during this process.
Okay. And the next one, is micro Kates supported as a remote Kate cluster?
Yes, so basically, yes, Gerardo said, at the moment it is possible to use an existing Kate cluster in OSM, and as micro Kates can be used remotely, it can be added as a Kate cluster to OSM if only exposed remotely.
Okay, the next one is quite a long one, is about the query for placement optimization solution. The first being a distributed architecture in 5G, where the Vim requires for all edge locations with UPF or only in Vim required in centralized location. If that's the case, if yes, then what is the maximum latency required between centralized Vim and edge site VNF, for example UPF, for placement optimization? And then finally, how are we optimizing cost with placement optimization?
Yeah, okay, that's one for me then. So basically, adding on to what Gerardo was saying, that the Vim is kind of reflecting a location. So that doesn't necessarily mean that you have to have like an open stack, a full open stack with the control plane and the worker nodes in every location. But it has to be like a logical, it reflects a logical location. So the first question I think is yes. We have a Vim for every edge location. And then, of course, the maximum latency is a question for the application and the use cases that you apply on top of that. So whether you want to have a particular latency in your application, then that's what the placement engine will need as an input and will take into consideration. And then, as I was trying to show, there is an infrastructure description that describes the actual latency between the different locations. So that is what the placement engine will consider and then deploy the VNFs, for example, the UPF, accordingly. And the cost is also an input, so it's a description. So that's something that the user and service provider or somebody needs to define depending on which purpose you would want to achieve. So it either reflects the actual production cost in your organization, or it reflects some bias. You want workloads to go into, for example, a central location. So you would set the cost cheaper there, because then most workloads that can go there will go there, basically.
Okay. I'm afraid we're getting very close to the end. Whether we can quickly do one, which is, does the placement apply only to VNFs, or can it be used with CNFs?
The answer is yes. It can be used with CNFs.
Yeah, may I add something here, just quickly? There have been questions related to the use of a cluster directly in OSM, like a bare metal cluster, for instance. Just in case it was not clear, it's pretty simple. You just need to add a Vim in order to add the target location, and then associate the cluster to that Vim. Okay.
Okay. Well, I think then we've come to the end of the session, and I would just like again to thank the presenters for the time and effort they've put towards this, and thank you to the audience for your questions and the time you've taken to do this. Thank you very much.
Thank you.
Thank you.